So our next presenter is Enes Turan. He is also the Google Developers expert in the field of generative AI. So he will share some knowledge about Google Kubernetes engine.
Yes. Okay. Yeah, welcome everybody. Actually today I talked about AI at a Digital Breach event, but some of you attended this event, so I wanted to I want to talk about something different. Yeah, I want to talk about Google Kubernetes engine. If you didn't hear about that, we can learn something about that and the management of the containers and the GKE features. So, yeah, as my friend said, I'm Enes Turan. I'm working as a cloud platform engineer. So, we say Kubernetes as most automated and scalable managed platform. We will go deep into these things. So, let's say we have some workloads, we have some applications, and we want to deploy our applications, and we want to make them available for our clients. So we need to use some kind of platform, and this platform can be different. We have different alternatives. For example, we have, let's say you have a source code and you want to deploy your source code. You can select a service, something called platform as a service, or you can choose a service like container as a service, or you can choose a platform, something like side as a service. You have many different options, or you can choose function as a service or Kubernetes as a service. So we have different options to deploy our applications. And so why we use Kubernetes? There are some prerequisites for that. So we have an application, a workload to deploy. And after that, if we want it to be fully managed, and especially managed by a cloud provider. So in this scenario, basically we are giving our responsibilities to the cloud provider, and the cloud provider says, I will take care of your application's infrastructure and how it's being deployed and managed in the infrastructural side and the networking side in the hardware. This kind of things will be taken care of by cloud providers. And also, especially Kubernetes is an open source technology. It was open sourced by Google like 10 years ago, and there was a technology called Borg inside the Google. Google was they were using Borg to manage their internal clusters, and after that they invented Kubernetes and published it. And at this time, the whole world is changed. And after that, there's a foundation created called a Cloud Native Foundation, and the maintenance of Kubernetes and the other cloud native technologies are handled by this non-profit organization. And also Kubernetes still is maintained by many different companies and users and developers. So let's say you deployed your application and you expected, let's say, 10 users, but one day you got millions of users. So your website will be shut down. You cannot handle this kind of requests. So because of that, we need to estimate our scalability, our performance, and our auto-scaling scenarios. For that, Kubernetes is one of the best solutions to scale your applications, your platform. Sometimes we need SLA. It means service level agreement. So your cloud provider guarantee you some kind of service level, some kind of uptime. Let's say they say, for example, 99% I will guarantee you the uptime of the platform. This kind of SLAs are important for the enterprise workloads and companies. And highly availability is very important. Let's say you have a company and you have on-premises data centers. You have deployed your applications into your data centers. But one day, one data center can be broken, can be shut down, or you can lose it, you cannot access it. For these scenarios, we need to have a highly available infrastructure and architecture. So basically, you are deploying your application to several availability zones. The zones are different data centers that's provided by cloud provider. So actually, you don't need to think about that. Cloud providers are actually maintain these kind of features. And let's say, for example, for databases, for SQL databases, if you use highly available clusters, you are dealing with and connecting with to one database, but at the background, a cloud provider automatically create new read databases and make them in a highly available cluster. So after that, if one data center, one zone can shut down, or they lose electricity or something, you don't have any downtime. And even you cannot notice this kind of events and incidents. So the pricing is very important, the cost optimization. Yeah, I know some of you have your startups, and some of you will start at big companies. So the cost optimization is your responsibility. You need to select a platform, a technology that like costs not much. So you need to select some kind of provided or managed solution, and it needs to be actually charged for consumed resources. Let's say you use your platform for 10 seconds or 10 hours. You need to be charged for 10 hours. If let's say a virtual machines are charged for basically they calculate it by seconds. But if you open your virtual machine you create it, it will start to charge you. So every time it will up to you. So you can close your virtual machine if you don't want to charge. But some kind of serverless workloads, they are charged when you use it, and if you don't use it, they basically don't take money from your account. It's important. But so let's talk about packaging. So we have applications, and we want to make our applications containerized applications. We need to containerize our applications to make them run in different platforms. This is very important because when you containerize your application, basically you make it available to run in different platforms everywhere, in different operating systems, in different different architectures, different cloud providers, different machines, different infrastructures. It's very important, and this enables us to run in consistent environment, run anywhere, and effective isolation. When we run applications in containers, basically we are providing an isolation between containers, so they will have their different their private network, or you can use container network solutions for that, and you can isolate them. For that, you need to look at some security features about containers, because if you wrongly configure your container, basically you can help hackers to hack your system, because if there's a security issue in your container, if a hacker goes into your container, he can easily jump into your system. So you need to be careful about configuring your containers and isolating their networks and their permissions, and at the C group level you need to isolate your processes. But at the end of the day, you will be having a very secure environment for running your application. I mean, we are learning how to code an application, but we usually don't learn how to deploy them, how to manage them, how to maintain them. This kind of containers and Kubernetes platforms actually help us about these kind of features. So we talked about containers. And when we look at bare metal solution, it's the on-premise environment. It's traditional way to deploy our applications. You need to be responsible about like hardware is on your control, and you need to deploy your operating system. And when you deploy your operating system, you are responsible also about like security issues and security patches and package updates and everything about your operating system. And dependencies, yeah, we have dependencies for our applications. Let's say you code or something, Python, JavaScript, or anything. You have different libraries, and these kind of libraries can be malicious, and you need to update them, you need to manage them. This kind of features we have need to be think about. And also you are writing your application code. Okay, bare metal solution, we need to think all these kind of things. When we go to virtual machines, you can just want a virtual machine from a cloud provider, and the hardware and the data center and its hardware and their internal physical network things are all on the cloud provider, and you are selecting your operating system, what kind of operating system you want and what's its version. After that, you are deploying your application. When we come to container, actually we are not dealing with operating system. You are just defining your image for your containers, and you are defining your application and its dependencies, and it's automatically download its dependencies into your container. Yeah, we talked about isolation, portability. Yeah, after you created a container image, you can use it and run it in anywhere, basically. You need to, let's say we need to an open source solution for the managing containers. We talked about containers, and we have containers. So we need to manage our containers. We have multiple containers, we have multiple services, we have backends, frontends, we have databases, we have anything. So we want to manage them multiply. So Kubernetes provides different solutions for orchestration. We call that orchestration to manage multiple cloud-native workloads, actually. So scheduling, scheduling a container, scheduling an application, creating an application, deploying an application. For these kind of features, we need a Kubernetes solution. It can automatically schedule your pod. It can decide when and where it should be deployed. Let's say your virtual machine is not working well. It has like its capacity is full, its memory full, its disk full, or its network access is not working well. This kind of anything, actually in Kubernetes there is a component called kubescheduler. It basically looks at every single thing and checks if your pod or virtual machine okay to run your pod, your container. So lifecycle and health, Kubernetes looks at your containers and your virtual machines, and if it decides your application or your container not working well, it can kill it and schedule in a new virtual machine. Scaling is, we talked about that, when you have a big amount of request, or let's say request, you can Kubernetes make your code and your virtual machines or your pods scaled up. Naming and discovery, actually it's important because we can deploy many different services, deploy many different pods, so we need them to be accessible with their DNS names or domain names, with their unique names in the cluster and maybe outside of the cluster. Load balancing is important. You need to balance your traffic. You can have many different requests. Storage and volumes, you can have persistent disks, you can have persistent data. For example, let's say you deployed your database, so you don't want to lose your data, so you need them to be accessible every time. Even your container killed and created again, you need to be accessing your data again forever. Logging and monitoring is very important. Kubernetes natively enables this feature. I mean, you can see your logs of your containers and your applications, your infrastructure site, and these are very important for resolving incidents and issues. Debugging is important. You can anytime you can go into your container and find the problem and try to solve it. Identity and authorization is important. Yeah, you can decide who can access your containers or which kind of resource groups or resource types. You can limit people to access to limited resources. So we talked about Kubernetes, and we have Google Kubernetes Engine. Actually, it is a version of Kubernetes provided by Google Cloud, and you can deploy your applications to it, and they can run on Google Cloud. Actually, there are many different cloud provider managed Kubernetes solutions. GKE, one of them, and actually it is one of the best solutions for that. It's as we said, it's fully managed. Normally, when you use open source Kubernetes version, you need to deal with many different issues. Actually, for the creation or for update for different issues, you need to be dealing with many different things and manual things. But when you use fully managed and provided as a service provided cloud GKE alternative or Kubernetes version, you are not dealing with this kind of problems. And secure by design, this kind of products actually by design they are secured and hardened. They, for example, they limit some kind of attacking scenarios for these kind of workloads. And reliability and workload optimized, yeah, they can easily scale up or scale down as your request or as your workload. So automatic upgrades is important. I mean, when we use Kubernetes usually have new upgrades, so you need to be upgrading your system, and you need to look at when you upgrade your system, if it will cause a problem on your application or not. You need to care about that. So for this kind of fully managed platforms, and they can easily upgrade your system, your version, and also you can track what's happening. They can send you alert about different things. Backup for Kubernetes is very, very, very different issue. Also, GKE and other stuff, they are trying to, this kind of cloud providers trying to give you a solution about backup your Kubernetes cluster. And CI/CD is very important. You need to be, I mean, you don't need to write Docker file for every time for your containers and trying to deploy them. You have a workload and CI/CD pipeline to deploy your application. And GKE, let's look at GKE architecture and GKE autopilot architecture. So we talked about GKE. We said it's fully managed and automated Kubernetes version and Kubernetes platform for you to deploy applications. Okay, we have also GKE autopilot. So in Kubernetes we have different virtual machines and pods. When you create a virtual machine, it will be called as a node for your GKE cluster. So you will have multiple nodes to deploy your pods, and pods are the containers actually. So in normal GKE standard version, you are also dealing with these nodes, and you are seeing this your nodes, and you can decide what is your maximum limit of scaling for your node pool, or minimum limit, or how to scale your clusters. You need to decide this kind of features. But in GKE Autopilot, you don't need to worry about your nodes. You can just deploy your pods, and GKE Autopilot easily automates the scaling process of your Kubernetes cluster. So you have a powerful UI. You can deploy applications from the dashboard, or you can use different methods like kubectl commands, or like imperative and declarative ways with YAML files. SRE monitored, yeah, for security reasons, or managing your cluster. These are all by Google actually monitored and managed. Automated repair apps, yeah, for your containers and for your nodes, they all repaired automatically. And resource optimized deployed, yeah, for GKE Autopilot, it automatically optimizes your applications and your deployments, and it can decide when it should be scaled up. Load balancing, auto scaling, these are by default our features. And also you can integrate your Kubernetes cluster with different Google Cloud services like VPC networking or persistent disk. You can attach a persistent disk to your cluster. Load balancer, you can use Google's load balancer or global load balancer and this kind of things. Cloud operation for automating the processes, you can use scheduler, cloud functions, pops up, this kind of features. I'm sure you heard about that. And storage services, yeah, and or for IAM services, you can use them for authorization things. And when you use kubectl, basically you are authenticated in the API server in Kubernetes cluster, in the control plane, and the managing of the control plane is not on you. Actually, cloud provider is managing the control plane and the nodes in autopilot cluster. So, what do you have? So, do you have any question? What do you think about these things?
Time for one question from the audience.
I can close this. Yes.
Hello. If container is full, then by K in GTE, it create another the same container or not? Or how containers works?
Yeah, okay. So basically you create a new container and you deploy your application. In this way, you can define a limit of the resources for your container. Let's say you can say it will use maximum 500 megabyte. Like these features, you can limit your resource usage. In Kubernetes, it can balance your traffic, and it can say, I want to create 2 pods of this container, 2 replicas or 3 replicas of this container, and I will down the request usage, down the resource usage. Let's say you have let's say you have 500 megabyte limit, but it wants 800. So basically, it replicates to 3 pods, and basically it make down this request. So with this way, auto-scaling and load balancing, it can automatically, manage your workload. Yeah. Any question? Yeah. Yep. Yeah, we have.
Hello. Thank you for a great presentation. I've got more real-world scenario that I would love to discuss if you could. And as in Google, you got low latency, very usable apps. And let's say someone is going to make some edit or payment with the Google website, and at that time someone deployed a new app version and it's buggy. So how Kubernetes handles that kind of request from user find the application while update, and what will happen when you roll back? So what will be with the request from user? If you got my point.
Yeah, actually, you can roll back to your old version, or it's up to API server. Actually, API server tries to handle that with kubescheduler, and you said if there's a conflict between users and their commands.
Some kind of race condition when the user clicks and makes some transaction, whatever, and that service which is responsible for that is kind of shut down or is not available because of update.
Oh, okay. Yeah, it's up to your application. Actually, you can you can define. Let's say you can say while there's a transaction you don't want to update or upload or you kill, you can basically define like graceful policies for that. Yeah, but after that you can check if the payment is done or not. But yeah, it needs to be tested. Yeah.
Let's give thanks and warm applause to Enes.
Okay, thank you guys.
So let's welcome our another speaker, software engineer at Google. So well, has any engineers here. Woljas Aypekov who will share some of his experience at Google